Introduction to rainbows. Rainbows are one of nature's most beautiful and awe-inspiring phenomena, often appearing after a rain shower when the sun comes out. They form a multicolored arc across the sky, captivating viewers with their vibrant hues. The science behind rainbows is rooted in the interaction between light and water droplets, which creates the stunning display. The role of light refraction. A rainbow forms when sunlight enters a raindrop and is refracted, or bent, as it passes from air into the denser water. This refraction causes the light to slow down and change direction. Since sunlight is composed of different colors, each with a different wavelength, the refraction causes the colors to spread out and separate from one another. Light reflection inside raindrops. After refraction, the light continues to travel inside the raindrop until it hits the opposite side, where it is reflected back into the drop. The internal reflection causes the light to bounce back toward the front of the droplet, where it exits. During this process, the light is refracted again as it leaves the droplet, further spreading out the colors. Dispersion of light. The dispersion of light is the key to the rainbow's color spectrum. As the light exits the droplet, it is refracted at slightly different angles depending on the color. Red light, which has the longest wavelength, is refracted the least, while violet light, with the shortest wavelength, is refracted the most. This separation of colors results in the distinct bands of red, orange, yellow, green, blue, indigo, and violet that we see in a rainbow. The formation of the rainbow arc. Rainbows typically appear as a circular arc in the sky because of the consistent angle at which light is refracted and reflected within the droplets. The shape of the arc depends on the angle between the sunlight, the raindrops, and the observer's line of sight. The lower the sun is in the sky, the larger the visible arc of the rainbow. Why rainbows appear after rain? Rainbows most commonly appear after rain because the atmosphere is filled with countless tiny water droplets. These droplets act as prisms, refracting and reflecting sunlight to create the rainbow. For a rainbow to be visible, the sun must be shining from behind the observer at a low angle, with the raindrops in front of them. The double rainbow phenomenon. Sometimes, a secondary, fainter rainbow can be seen outside the primary rainbow. This double rainbow occurs when the light is reflected twice inside the raindrop before it exits. The colors of the secondary rainbow appear in reverse order, with red on the inner edge and violet on the outer edge, due to the additional reflection. Rainbows in different conditions. Rainbows can also occur in other conditions where water droplets are present, such as mist, fog, or even waterfalls. These scenarios involve the same principles of light refraction, reflection, and dispersion, but the resulting rainbow may be smaller or less intense. Conclusion. Rainbows are the result of the intricate interplay between sunlight and raindrops, involving refraction, reflection, and dispersion of light. Their appearance after rain showers is due to the abundance of water droplets in the atmosphere, which act as tiny prisms to create the colorful arc. Understanding the science behind rainbows adds another layer of appreciation to these natural wonders.